Our next study is going to be about linear models. And linear models are where we turn information that we're given into some kind of graph. And as the name suggests, this will actually be a linear graph. And that's what we're going to look at now. There are generally two ways that we can be given information when we're asked to create a linear model. One of the ways is that we're given some sort of starting point and some kind of rate. And from that, we can create an equation in the form of y equals mx plus c, where my rate will be my gradient and my starting point will often be my y-intercept. Because the gradient has to do with a rate, look for certain words that imply there is a change. So something like for every something. So it increases by this for every something, or the actual word rate, or per. These sorts of things are all rates and they'll all have to do with gradient. Often you'll also be given a starting point. So if I had some business application where I was told somebody started with $100 and then they increased that would be a plus, by $200 per month, then I know my gradient is $200 per month, and then that gives me a whole lot of information for my graph. First of all, it tells me my y-intercept is going to be at 100. It also tells me that my y-axis is going to be measuring money. Then when I have a look at my gradient or my rate, I can see that my slope is going to be 200. So this graph here will have a slope of 200. It also tells me that my x-axis will be time, and that'll be measured in months. So there's a whole lot of information that I can be given, and I can find very quickly in my sentence that enables me to quickly and accurately sketch a linear model. But there's another way you might be given information. Rather than be given a rate and a starting point, sometimes you might just be told two or more points from the graph. So you're not actually given a starting point or a rate, and you need to work them out. An example of this could be someone filling a swimming pool, and they might say after 1 hour there are 1,000 litres in the pool, and after 4 hours there are 4,000 litres in the pool, and therefore you need to find your gradient and your y-intercept. The way to do that is you form the points and you make your coordinates. So my first coordinate would be 1 and 1,000. And my second coordinate would be 4 and 4,000. And by using the 2 points, you can create the rate and the starting point or the equation of your graph. The first way you'll do it is you'll look at my rate being the rise over the run. And it's always a nice idea to sketch this so you can actually see the 2 points and you'll be able to work out the rise and the run. Once you've calculated the gradient, then you'll be able to use one of the points to substitute in and get the actual equation. because what you'll find is you'll have some number equals some number times another number plus c, and you can solve for c. Remember, once you have your gradient and your y-intercept, you have your equation. If you found this or any of my other videos helpful, please subscribe to my channel or like the video. Thanks.